My name is Jose, as I was introduced. I'm a senior DevOps engineer working for Amadeus, and today I will be telling you a story about code-defined observability, from the provisioning of resources to its assets that enabled us to create and manage and deploy thousands of Grafana dashboards and Prometheus alerts, and most importantly, survive to that to tell you. So before we get to the meat of the talk, let me introduce you why observability matters to us and why we embark on this very journey. So for those of you that never heard of us, Amadeus, apart from a national icon here in Austria, Amadeus is a fairly big IT company in the travel sector. So for instance, who of you came by here by plane? All right, true, thank you for paying my salary. Love. Right, so yeah, we have quite a geographically diverse workforce of about 16,000 people, half of them being actual developers, and we are honestly all over the place when it comes to travel. So usually people don't know us, but if you go to a travel agency, it's gonna be Amadeus behind the scene. You go to an airline website, again, Amadeus behind the scene. You go to the airport to do the check-in, again, it's gonna be an Amadeus terminal to do the boarding, flights balance, Amadeus again, and so on and so forth. So yeah, we are into airlines, rail, hospitality, and so on and so forth. So given all these numbers, you might actually realize that there is no mystery that incident management, powered by observability, is non-negotiable for us. It's something very important for us, as we have to manage thousands of dashboards and alerts for hundreds of airlines, airports, or hotel providers, among others. So that is why we embark on this crazy journey altogether. About 2 years ago, we decided to go full on to the public cloud with cloud-native technologies, kind of a major project, as we have huge data center not that far from here in Munich, where I actually work from, and a couple of small ones distributed all across the world. And we actually ran quite a fairly big system, I think it's fair to say. So I'm going to give you a bit of an insight. Number one is the volume transactions with 1 million transactions per second that we manage. 100K of them coming from the external world, what we call the shopping traffic mostly. And interestingly, if you put that into comparison with Google Search has about 100,000 transactions per second. So same as us. So a fairly big system when it comes to traffic. Now, in over more than 2 decades, we have lived quite a number of technological revolutions and transformations, from the digitalizations of bookings that were traditionally made by telephone, the first steps on the World Wide Web, our adoption of open systems with Linux, containers, infra as a service, you name it. But about 2 years ago, we kicked in, which was probably our biggest ever technological and human transformation in about 30 years. We did not only kick in a wide-scale DevOps transformation, but a full migration to public cloud with cloud-native technologies and a drift to GitOps and everything as code. So we are indeed living a huge engineering revolution, and we are revamping all of our processes right now, including as code observability. You're going to be hearing this one for a while, as you will see in a second. So yeah, we're in the middle of this huge transformation, so if you would like to be part of this journey, we actually have a couple of exciting opportunities if you want to check it out. But enough of context. As promised, let's go to the actual tech. Right, let's talk observability. We do indeed have a consolidated stack among our, let's say, legacy stack in our data center with 10 OpenShift clusters that are monitoring 30,000 VMs in our data center and producing something like 300 million time series. So we actually have the same stack in the legacy as in the public cloud, which help us to go and, for instance, compare our response time with the workloads that have already been migrated to the cloud. So we started to implement Thanos on top of the Prometheus stack to horizontally scale, let's say Prometheus, which enabled us to have a single data source, thanks to Thanos. In 2021, we actually did sign a partnership with Microsoft, which meant that we are now deploying a lot of clusters. So last time I checked, about 2 weeks ago, we managed to have about 90 OpenShift clusters in the Azure public cloud. I'm sure a couple of more probably in the meanwhile, and 10 on-prem. And we'll probably have to double up those numbers by the end of the migration. So thanks to the automatic installer of OpenShift before and this operator all the way approach, we were able to seamlessly deploy that many platforms where we currently have about 1 million active time series. Now, how is that possible at scale? Well, by everything as code. As I said, you're going to be hearing this one quite a lot. So we actually do have an end-to-end self-service bootstrap process, orchestrating the installation of a full Azure subscription, deployment of the OpenShift clusters, registering them into Argo CD, and deploying all our internal middleware, such as our observability stack, this one, that allows needs to deploy the applications. So in this workflow engine that uses TerraGrant and Terraform under the scenes, we managed to build all Azure managed services, that is Key Vault, subscription, and the OpenShift installer. Once OpenShift is installed, we register the cluster in Argo CD in a special OpenShift cluster that we have that is central and serve a bit like a control plane. And thanks to the cluster generator and Helm charts, in Argo CD, we're able to deploy all our observability stack with the rest of platform components in a newly created cluster that we have. So as I said, we're going to have, we actually do have everything as code with even an operator that enables us to push Prometheus alerts into clusters so that they get automatically monitored. But for the rest of the talk, I will be talking about the observability assets, not that much about the provisioning of the infra and resources, all the observability assets, that is dashboards and alerts, mostly dashboards. So let's get to it. In our approach to observability, we do have built a comprehensive toolchain that we provide platform users the possibility to build, test, and deploy dashboards and alerts as code. So the end user, by providing JSON-net source files and by using our existing inner source templates, which are no more than JSON-net libraries, they are able to instantiate dashboards in Grafana. So we want to wrap it all up in a Go module, relying on open source modules, such as JSON-net for the templating part, JV, the Fiddler, prompt tool, and so on. That can be called either via CLI, either locally, or in the CI. So yeah, by making a simple pull request, users can get a quick feedback loop with a dashboard snapshot and get it deployed whenever merged back into the release branch. So yeah, let's try to see how to build a new dashboard, right? So this indeed how a simple dashboard looks like. It is actually a simple JSON-net file that imports our Amadeus Graphonet library that allows us to instantiate a new dashboard based on a title, unique ID, selection, description, and SCM details. So as introduced, by using our DAC CLI, which in short is dashboard as code, you can indeed build, deploy, and statically validate this very dashboard that we created. So let's look at the very first of these CLI commands, which is the one all, which will both build and deploy the dashboard that we just created before. So you can see here in the screen, in this screenshot, it will go and fetch the library dependencies that are established in the JSON-net file. And the other interesting line is the very last one at the bottom that showcases the snapshot dashboard that were created in an isolated Grafana folder. So indeed, very simple one. You have here one empty one with a row that showcases basic dashboard information, point of contact, and SCM details based on the input files and the link to the source code to allow for people to modify that. So yeah, you can already grasp a bit of the magic of templating, just a couple of lines, and we have a consistent metadata across all our dashboards in the company. But get ready, things are going to be a bit more complex than this. We just started. Something that we do indeed is to make the dashboard read-only on the UI, so that users are indeed forced to edit them via Git in the version control link that appears there. And it is actually a good way to ensure that, as we mentioned, everything we do is as code with all its benefits, right? Now, let's get into a slightly more complex dashboard. Let's try to visualize some data from the metrics of a Prometheus counter, which contains HTTP responses. We input two stuff, which is Kubernetes namespace and HTTP status codes. So in this case, as you can see here, we use a time series panel template that can indeed be reused in different dashboards, as you will see in a second. We provide a list of available levels and a query template, and the magic to translate it to the actual PromQL query will happen all in the background. And likewise, we can build selectors to enable filtering capabilities to the panel that you saw before. Like in this case, we actually do pass the exported namespace as a filter to the panel. Voila, we got it. Templating magic happened, and the actual PromQL query that you can see down below is automatically computed based on the inputs that we provided. Everything happening on the template itself. Now, let's go a bit farther. Let's try to add 2 more panels in this layout, right? So we might have like 3 side by side. And instantiates the same template, but now with a new filter to view 400 HTTP errors, which we can name client errors. And in the second panel, and in the third panel, we can showcase 500 errors, which we will name server errors. Right, so let's run it. Boom, easy. Just 2 lines and 2 more graphs. Now we have a layout with 3 columns. You can see now, you can actually grasp here the magic of templating dashboards. But let's get a bit more picky. Let's go into the design area, and let's try to turn the errors to be red. Right, so small changes. In this case, we can extend our panel template and add a new template target dedicated to errors. We're going to turn it red. Now it's only 1 panel for errors, both of them, and both of them are going to be red. How we can actually get both? By grouping them in a clause to display both the 400s and 500 in the same panel. So let's get it running, and there you go. You can see them in the right, and the instantiated PromQL expression down below. Cool, right? Now, we actually hard-coded the namespace, if you remember. But what about the others? We have, as you remember, we have 90 clusters, thousands of namespace. Well, we can introduce them as well as template variables. And we can tell Grafana to get the list of namespaces from a given metric and alias it to the exported namespace, which is super useful whenever we allow for drop-down capabilities in Grafana and so on. So it's fairly easy. We just put it there, and that's what happens. It's on top adding and using this very template variable to allow us for interactively filtering the dashboard itself. Very useful as well for drop-down filters. Now, you already saw the power of templates. And with JSONet being a very powerful templating language, you can let your imagination fly. You can go as crazy as you want. So nothing prevents us to create a new row per namespace, right? So let's do it. As you can see in the loop clause right down in the slides. There we go. Now a very nice matrix of 9 panels, which helps indeed our incident response teams to monitor our service in detail. It's very easy to actually get all sort of drop-down dashboards right there. We can even go and create a new dashboard per namespace, right? So if the DevOps teams are able to check only their own applications. So we can do this easily by turning it into a list. We make it a list, and then we will actually have them created. And just like I showed before, together with the build command, we have our deploy capabilities in the CLI, so that those are actually automatically updated into our Grafana instance, into the dedicated folder. So this is indeed the secret, as I mentioned at the beginning, to build thousands of dashboards and alerts that we went through. And obviously it would be crazy to do it manually, for sure. So we have dashboards of all kinds, per client, per application, per function, or per service. And everything is just a matter of just templating logic. Now, school templating is quite nice, but as code means quite a lot more, right? A lot as code means much more than just having your assets being declaratively uh, uh, contained. So just like any other code base, just before committing it to your repository, you have to test it, right? So myself as a developer, converting into ops, I particularly love as code in that it enables all processes that I love as part of the software development lifecycle. So we can do the same for dashboards and alerts. As much as you can test your code, you can turn your dashboards to code, and you can also test them. So JSONet comes with a number of testing frameworks, such as this one that we are using, which is the JSONet Handler or JSONet Unit, that allow us to unit test your dashboards, which we include it off the shelf in our binary. They will be invoked as long as there is a corresponding file with the underscore test suffix, as you can see right there. And yeah, development experience, right? A couple of nice talks happening in this conference, and DevX matters, right? So luckily, you can actually run it locally as well and get instant feedback before actually committing the code. Testing should be easy, indeed, development friendly, and as close as possible to the ID. So we actually enable it off the shelf. And everything should be tested. I'm just showing a bit of the unit test, but you can also test the corresponding PromQL queries. So yeah, once you have your dashboard ready locally, you are ready to make a commit and make your pull request. Whenever you do so, we have created an internal Jenkins shared library just for us, but it's very easy to apply that into your favorite CI because just a self-contained Go binary. So we do have a Jenkins shared library, just 2 lines to get all dashboards in your repository built and deployed magically for you. It will ensure that the dashboards are statically validated and tested. It will build them and deploy them as snapshots, which the developer can actually go and click and check out interactively. So this is actually quite useful, and together we also do some sort of reconciliation mechanism to know which ones have been changed, and we also provide the diff, what you have changed in order to roll back or so on. And in the interest of time, I will be stopping here on the dashboard front, but there is much more that comes out of it. That is ID integration, linting, testing, creation of libraries, everything off the shelf that we included there. Lastly, we also use this same project to instantiate Prometheus alerts. It's sadly the same logic, just a couple of more tools, like prompt tools that we have integrated in the whole module. But as they are using a custom alerting fact set that we have and custom operators, we have decided to de-scope it, and we will not be able to open source it. So that's why I didn't talk much about the alerts, but the same logic applies. Same magic can apply to alerts. What worked well for us? Quite a lot of learnings through this experience. One of the important learnings is they focus on development experience, as I mentioned, getting started with a very simple command that will be able to scaffolder your repository with that in it. One CLI that it's able to perform all the actions, quick feedback loop for the user in pull request, they used codes, local dev setup, ID configuration, and verifying that the workstation is set up correctly. Another thing interesting to mention is that as code comes up with quite more things than just declaratively setting up your assets, such as linting, testing, and testing. Usage of Golang, another big enabler, the fact that you can easily install an off-the-shelf CLI. Most of the ecosystem that we have in the CNCF is Go, so you can easily plug and play. And another important thing of Go is that it enables concurrency, so it's very easy to actually deploy thousands of dashboards concurrently, and don't care that much about the performance on that. And yeah, we are leveraging existing ecosystems such as JSONet, Grafana linter, Grafana cron tool, and so on. And I wanted to thank all the contributors to these projects that were there. Now, although the project is just putting together open source tools and already existing already existing, we thought of going and open source it all together so that you all can benefit from it. But a bit of sorry, we're actually late and we didn't manage to release it yet. It will come in a couple of weeks as we are still polishing it and removing the internal dependencies. But if you are interested in it, the repository is already in GitHub. We'll be releasing it so you just add a star and tune in and you will see that in a couple of weeks. And of course, once it's done, contributions are more than welcomed. Now, you might be wondering, where's the catch? I was talking about cloud native observability, right? But only one slide was about cloud native stuff, right? I'm going to introduce you a project that some of you might have heard of, and some of my colleagues in Amadeus are actively working on, which paves the way to go full GitOps and cloud native all the way. It's actually called Perses. You might actually have heard of it, which in this case is already available in GitHub, so feel free to go and check it out and even use it. And it will go to present a high-level overview of it. But if you want to deep down into internals, I can happily connect you with the developers that are behind it. So let's look a bit on the why, on the motivation of just creating yet another dashboarding project. So you're looking at the CNCF landscape in the observability area. You have many backends to store your logs, to store your traces, but there is nothing to display your data, right? So Amadeus, thanks to the help of Chronosphere for sponsoring the project, some of my colleagues are currently developing a vendor-neutral visualization tool with a standard dashboard format to propose to hopefully be part of the CNCF landscape at some point soon. So if you're interested on the topic, there will be a huge presentation indeed in PromCom Berlin in a couple of days or weeks, I don't know. So feel free to tune in. Yeah, so thanks to Amadeus and Chronosphere. So we want it to be GitOps friendly, and by learning from our experience with the Dashboard as Code project that we showcased before, we want full stack validation on the dashboards natively with a CLI and a QLang schema so that you can validate your dashboards in the CI, whatever your technology, GitHub, GitLab, Jenkins, whatever. We want it to be fully cloud native and compatible with Kubernetes. That means deploying your dashboards directly in Kubernetes via custom resources, right? And later we will also like to have data source discovery at some point. And because you learned that it can be painful to edit your configuration locally and tune it, as I showed you before, even if the data model is great, you should be able to run Perses locally as well to edit your configuration files that you can commit and let your GitOps engine reconcile it and apply it on your behalf. So that's a bit of the motivation behind. Now, one of the key benefits of this one is the fact that we are aiming to make it embeddable. As we all have the same issues in all of our tools, right? So we all want to display our data, but it's really a pain to go and install yet another tool just to display that very bit. So there are a number of packages that you can indeed import in your own UI to display your metric, traces, and even logs in the very same place. Quite nice. And as you know, Chronosphere is already importing this package, as you mentioned. Red Hat indeed is considering this package as well to improve their OpenShift web console and to include some metric UIs there. And there are some discussions for Prometheus, PromLens, and why not even Thanos, or perhaps Alert Manager as well, to include it as part of their UIs. The roadmap of Perses is to support everything in the observability area. We started with Prometheus to display metrics, but it's aiming to also display traces and logs, like one for all. And if you're interested in this project, as you mentioned, it is already available in GitHub with a chat available for you guys to interact and ask any question that you might have. And there are clear contribution guides if you want to contribute to the future of cloud-native observability. So that is from my side. Thank you very much.
Thanks a lot, Jose. It was really insightful. Also the Perses stuff at the end. Who is already familiar with Perses? Is anybody using it? Who heard of it before this talk? Okay, so everybody learned something.
Oh, yeah?
That's perfect. Cool. Are there any questions? Please raise your hands. I see one hand there. Perfect.
Be right there. Hi, thanks for the talk. I was thinking about how you manage the state of the dashboards. You mentioned something about diffing something. Can you elaborate on that?
Right, so that's a bit of that's why I never mentioned GitOps until the very end. So one thing is as code and the other one is GitOps. We are missing a bit of the reconciliation part. We do actually do a simple hash map comparison between both of them. So at pull request time, we actually find which MD5 have changed in between them, and then go and edit it. We are not recreating them all the time, so we have a very dummy reconciliation mechanism on our CLI. Just look through, and hopefully at some point, whenever we go cloud native with Perses, there will be our capacity doing a bit of reconciliation and finding out which is the one deviating.
Awesome, thanks.
Right.
But you had the operator framework on one of your slides, right?
Yeah.
So I assume you built your own operator for this reconciliation stuff, right?
So the operator is for the alerts. So I've been mostly talking about dashboards. Dashboards are just pushed into Grafana.
Okay.
That's one off, and there's not that much of cloud nativism there. That's why.
Okay, cool. Any further questions?